Uh, Beautiful. Well, welcome back. It is, what is it, Thursday. And today was PPI, which after CPI really didn't expect much out of it, but it was massively hotter than expected. They're still probably going to turn this thing green. I mean, it's amazing. The dip buyers, the bulls came in, tried to sell it off. And it's weakening now, but still, I mean, SPY's down 21 basis points. Not a whole heck of a lot going on. The biggest thing is Bitcoin's taking it on the chin after testing. Actually, I think it broke through all-time highs like overnight, and now it's like 118. So that is somewhat painful for me, but is what it is. We'll see where they end this thing, whether the bulls can actually finally gain some traction, or whether the dip buyers just buy up every dip. I don't know if I mentioned it. Wall Street Journal wrote an article about this a few days ago, how there's this whole new generation of dip buyers that have never really seen a downturn. So they just buy everything blindly. I think there's a whole lot more to it than that, but certainly market dynamics, have changed. Whereas maybe in the past we would have sold off big on that PPI, and now, I mean, theoretically we could close green. So interesting to watch out for.
So are you long Bitcoin directly, or are you short the puts, or where do you feel? Where are you on that? Are you
Yeah,
protected a
no,
little bit?
yeah, I mean, I don't buy direct Bitcoin. Everything I do is options. So, yeah, I've got a whole bunch of different things on IBIT. I got ratio spreads, I'm short puts, I'm long calls. I got a whole bunch of stuff going on IBIT, and then, a couple of the crypto treasury companies, and then also, the Ether ETFs as well.
Got it. So we have VIX up here, and because I was asking Matt off camera about VIX. Max, want to explain what's happening with VIX right now, man?
Yeah, I mean, VIX is pretty much dead, even with a little bit of a sell-off today. Let's update it. Yeah, I mean, it's up 3.73%, which for VIX is really nothing. The thing I would highlight, I mean, yeah, VIX is at 15. Thing I would highlight, though, is during Trump #1, VIX was in the eights for a long period of time. So for those who say, hey, VIX can't get any lower, yeah, it can. That being said, I did buy VIX calls yesterday. The cool thing about VIX is when it does spike, it spikes hard. So, like, here's Liberation Day. It got up into the 50s. That's like almost, I mean, almost 4x from where it is right now. If that happened again, and who knows whether that'll happen again. But, if it did, I mean, my calls go through the roof.
So would you
And
call that like cheap insurance, or not really?
yeah, I mean, the time you want. So I always, the heat formula, H for hedges. I always have hedges.
Okay.
What those hedges are can change. And, with VIX just dying, I have not had a VIX hedge. I've been doing stuff in SPY and IWM and ARC. I also bought some ARC puts this morning. I've been short ARC calls for a while. Yeah, but I figured yesterday, you know what? Yeah, VIX could go to 8, but now is a good time as any to buy some VIX calls.
Got it. Okay. All right, Jeremy, how about you, man?
It, I was going to agree with all that, and then the benefit of running VIX calls, I mean, it turns your hedge into an asymmetric risk as well. So it's if it loses, it loses a little. If it wins big. So it's like having cheap insurance, but with more of I guess a broader coverage. Like, instead of getting the $20,000 thing, you get the $200,000 thing. Anyway,
Got it.
Looking at a lot of other stuff here, and I like to watch QQQ. QQQ is one of my favorite trades. Last time we were on Tuesday, I called out it was likely to close around 580, damn near to the penny. It did. I'm never wrong. Come on now. Going into today and yesterday, it was fairly flat. It had that little sell off. It gave half a move back from the previous day, and now we're kind of hovering around that level as if we're waiting for a shoe to drop or something. But the BTFD crew, I like to call them, came out and bought that dip again this morning, and now we've seen a little bit of the liquidity change hands. But other than that, it's kind of right back where it started, more or less, in yesterday's mid range. So where we go from here? Well, it's still pretty bullish. We do have a point there. We do have a target up around 586, 587 for QQQ, respectively. But that's kind of after a bit of a parabolic move. So there's going to be a little bit of caution going into this, and we can kind of see that with a little bit of pickup in the VIX. But for now, it's still looking pretty bullish. What did get hurt, and I'm grateful it did, was small caps got a little bit of a sell-off today. As you may know, I do wheel trade TNA. By some miracle, I was not early assigned on my covered calls yesterday as they closed deep, pretty good in the money. Now they're out of the money again, and I'm happy and all is right with the world. So we'll see how that goes. But as far as the small caps go, it's not really a beat down. It's more of it took an impulsive move and kind of gave half back. So it was expected on my end.
All right. So BTFD means buy the F and dip. Is that right?
Yep.
Got it.
I call them the BTFD crew because it seems to be all about it.
Sweet. All right. All right. So I'm going to introduce our guests here. We have Max, Ankur, and Bahn from Rocket Propulsion Systems, right? Max is a CEO, was at, SpaceX, Firefly, a couple other spots you probably know about. These guys, I'm going to try to sound like I'm not reading right off a script here, which I am. They're based in Washington. They focus on designing affordable, scalable cryogenic engines and orbital transfer vehicles with impressive specs like 3,300 pounds of full thrust and vacuum of 374 seconds. All right, guys, how you doing? Can you explain what that means real quick, like the pounds of force and vacuum, why that's so important, why that's so impressive?
Yeah, so pleasure to be here, guys. So yeah, let me explain what it all means. Our engine uses cryogenic fuel, right? It's extremely cold fuel. You carry it as a liquid in your fuel tanks. The engine itself, it weighs 33 pounds. So it's like a medium-sized, large dog in size.
Right.
And it can pull something like a Ford F-150 truck. That's the thrust it develops, right?
Right.
The way it's used is you can put it on vehicles that can be used in space to do some jobs. And one of the vehicles we're developing is this orbital transfer vehicle. And that engine is essentially powering that vehicle in space.
Got it. Okay.
So
All right.
how would I mean without your engine, if I'm flying something around, what am I using now?
Yeah, so without the engine, the status quo right now is that you're limited to engines that are much lower in thrust, or in their capability to move things fast, right? Majority of the engines that you can select from are of that nature. Now, there are some unique engines out there that are like our engine, but the rub is that now you're talking about several $1 million per engine. Whereas us, we come in and say our engine is just $150,000. So orders of magnitude of cost savings.
That is the orders of magnitude.
To do vehicles.
So then the vehicles who are using your engine, so you're not lifting off from the earth. What you're saying is something lifts off from the Earth, the vehicle's inside it, it can pop out, use the engine, go back in, pop out, go back in, that type of thing?
Right. So specifically for the use case, for this specific use case, that's the case. That's right. Right. Our small orbital transfer vehicle, it would be lifted, launched from Earth as a payload on a larger rocket, right? That larger rocket would release it into the orbit, and then our vehicle, this orbital transfer vehicle, goes off and does its job. And by the same token, anybody who is aspiring to make a vehicle like this has an option to buy our engine too.
Got it. And so I see here where the normal engine of similar performance you say are like $1.5 million, so you're like a tenth the cost.
That's correct. Yes. So
Got it.
we've gone through considerable amount of innovation and IP development to get the engine down to that cost level.
Got it.
which makes it
Okay.
very scalable.
Right.
It is scalable. So let me elaborate on this a little bit. The architecture that we started this engine with, right, is such that it's highly adaptable to changing requirements. So for example, you have mission 1, you have mission 2, and there's slight changes in the thrust levels or the packaging of the engine. And so what our engine brings to the table is that it is adaptable. It is highly adaptable. And we achieve that through some manufacturing technologies that are built into this engine.
I see.
Very cool. You can kind of turn the volume up and down. You can change how much force you're putting in, and it's used primarily for transfer, but also it can be used for vectoring. So I mean, most satellites, well, a lot of the bigger satellites have like little built-in engines. They can change their vector a little bit, but everything in low Earth orbit, it's in a decaying orbit, and eventually they need a little boost to get them up. Is your engine able to do that? As able to put satellites back in orbit?
Correct. So with the common engines out there, right, that we've spoken about, the ones that are low thrust, you can still do orbit changes and those are orbital operations. Now the rub is that those are going to be proceeding at a slow pace, right? So we're talking, say you have a satellite in orbit, and you want to change its position, move to a higher orbit or move to a different orbital plane.
Right.
So those kinds of maneuvers, they may take weeks and months on end. Our engine, what it does is it reduces this maneuver time to hours to days. It depends on the orbital change maneuver itself, but orders of magnitude again of speed increase.
Right.
So that's cool. For a lot of communication satellites, I can see that that'd be highly beneficial because a lot of the time their orbit position is very critical, along with their speed of orbit too. As everything changes when you have a decaying orbit, things have to go faster to stay in orbit or they deorbit. So that's
So I read on your website
So,
here that let me ask a question. So I read on your website here that like you guys are, maybe these reused engines are targeted to be sold at 1/6 of a price of new engines. That whole reusable engine, can you talk about that? Why that's important?
yeah, so our company, right, we are working on several different product offerings, so to say. The engine is one of them. The OTV, that orbital transfer vehicle, is another one of them. There is another suborbital rocket product or missile that we're working on as well. That's a third product. Eventually, what we want is we want to be playing in all these niche sectors that cover space in general, right? Missiles, launch vehicles, OTVs, engines. So how does engine reusability tie into that? So if you
Yeah.
take the launch case out of those various cases in the future, for launch, engine reusability is important because you can land the booster back, refurbish the engine, and go again. And so on launch number 6, you're essentially flying free
Right.
if you keep reusing your engines in the booster stage.
Got it. Okay, so that makes sense. So I'm going to just move on here a little bit. So you guys have a couple of government contracts. You just got one from the SBIR, et cetera, et cetera. You want to talk about those a little bit?
Yeah, so we have a pretty close relationship with the government. Since the start of the company, we've been contracted with NASA, National Science Foundation, the Space Division there, and the Space Force. We are finding that our products are getting traction with the government, which has been a blessing for us over these past 6 years. Yeah, this latest Space Force contract is a $3 million contract to develop the OTV for dynamic operations in space. Again, this is to support this rapid maneuverability in space,
Got it.
which is relevant for the next few years as the geopolitical situation develops here.
We've talked a lot about that. So, as I explained, we're really big into kind of thematic investing and looking, not just what are today's themes, but what's tomorrow. And it's obvious that there's going to be a lot more stuff in space. And one of the things we've talked about a lot about that is that, that obviously creates some advantages, but from a security standpoint, if North Korea wants to come at, one of our plants that's in America, they can't really do that. But if they want to go after one of our, something we have in space, that's a whole different story. So, I kind of envision, I don't know if you guys have seen, some of the James Bond movies, but, that kind of scenario where you've got the thing that comes in and sucks up things, and then you've got the guys with lasers, shooting at each other. And, I would think that from a Space Force standpoint, reusability, because you never know. You go out and you deal with the threat, you come back and like, oh crap, we got to go back out again. And speed are going to be the most important things.
Matt always goes to that James Bond.
I
Man.
know.
He's like 3 for 3 on that.
With Amazon owning the Bond franchise, they might be.
Yeah, exactly.
Right.
I like that. That's a theme.
Like a
That's like
sequel
second order
right
thinking
there.
right there, Matt.
Yeah.
All right. So this kind of ties into my next question, like Golden Dome, right? You guys are in the Golden Dome. That's one of our themes, right? So where do you fit in that universe?
Probably nowhere, but
Yeah, so just to latch on to Matthew's comment there, right? And that kind of segues into the Golden Dome conversation as well. We as a country, United States, it has a lot of satellites in space, and we have them in these intricate formations in space, right? If you can imagine complex geometric shapes, and at each of the nodes of that complex geometry, you have a sensor. And that sensor is looking back at the planet, and it's looking at the competing nations and what they're launching on any given day and whatnot. And so the other competing nations, they're struggling hard to have the quantities and the complexity of these constellations in space. In other words, they don't have them. And so that creates a natural threat to them, security-wise, to catch up with something, with some response, right? And so the response at the moment is to place some sort of offensive technologies into the orbit, right? And our response as a country is, what do we do about that, right? And the Golden Dome comes up as an idea to counter those future threats, those future capabilities that they may develop and place into orbit. And so Golden Dome itself, that's a significant, in other words, huge endeavor, right? We're talking about 4 different layers in the system. There is the small range, the mid range, and the far range missiles in a traditional sense, or interceptors. But then the 4th layer is this orbital in-space layer, right? And so the idea behind that higher layer is that you have these sensors in orbit. In other words, the satellites that are equipped with vision ability, but in addition to vision, they also have capabilities to move fast and execute on a specific mission. And that mission could be a defensive mission or an offensive mission. And so the way we come into this picture is we kind of tie into that higher layer of the Golden Dome, and we potentially form one of the formational elements in that upper layer with our OTVs that can move rapidly at the low cost.
I got a follow up for that, right? So, do you think like the Golden Dome is one of our themes? Do you think that's like too much to chew? Like there should be like Golden Dome first layer, Golden Dome second layer, Golden. I mean, it's a big thing. I mean, do you think there are within Golden Dome? I mean, are each one of these first through 4 layers completely separate things, or is this one massive thing?
Pat, this is an excellent question. So in my opinion, right, it is doable. Now, the budget estimates for the Golden Dome enterprise, they're, the range is pretty wide, right?
Right.
The estimate goes from anywhere from 150 billion to something around $1 trillion, right?
Right.
But from a capability standpoint, the first 3 layers, the intercept layers, are basically there, right? We have the Patriot systems, we have the Aegis system with the Navy, and other systems. The kinetic kill vehicles, they're present, and they're developed and they're fielded. Now, this upper layer, that will take some development, but the good news is that in our country, right, we have firms like ours that are actively shaping that discussion and the technology itself. And so, I believe that in the next few years, there's going to be quick down selects by the government, kind of converging on what the viable path is to fill up that upper layer.
Right. And I mean, so that's a good segue to what we talk about. We talk about companies, stocks, et cetera. So who's in that upper layer space now? Is it, the big guys, is there anyone who besides you guys is in that space? Any publicly traded guys, I guess is the question.
So Firefly went public just recently, right? And as far as we know, that's the only publicly traded company right now that has participation and does developments in that arena. There are other companies, but they're privately held right now. But I can tell you with high level of confidence that there are on the order of 10 different companies that we know of that are actively playing in this area.
Are they competitors of yours, or are they kind of ancillary services?
So it's both, right? It's, if you think about it as more of an ecosystem, right? And there being multiple different players and kind of, and each of them complementing each other, right? From a capability standpoint, who does what? For example, in our specific niche with the OTVs, there are some significant players out there that make larger vehicles. that can move fast,
Yeah.
but they're more expensive, right? We come in and we say, well, we're going to take care of the smaller vehicle size at a low cost. So kind of take that part of the spectrum. There are other companies that come in and say, well, we can offer something that will achieve something like an intermediate speed for that maneuver in space. And so it's a spectrum, if you will. And but the good news is that everybody is moving on forward, right, to kind of fulfill those objectives for that upper layer.
And when are you guys going public?
So going public is on the table for us. It's definitely an option. In terms of when and how and what the conditions will be is still an open question for us at the
All right.
moment.
Hopefully it'll be a SPAC so we can participate. We run one of our ETFs is a SPAC ETF.
I gotcha. Yeah, SPACs are something popular nowadays. So yeah.
On and off.
Mm-hmm.
So
It's a hit or miss, I gather.
Yeah.
as a bit of a second order thought, I had a question as far as all of the components and parts to those components for your systems. Are they all manufactured in-house, or is there another company making all the parts?
Yeah, so this is partially where our innovation and IP comes in, right? We strategically outsource some parts and operations out of house, and some we make in-house, right? So some parts are, for example, additively manufactured or 3D printed, and some parts are commercial off the shelf. And so by smartly combining several different methods, outsourcing, insourcing, we arrive at that low cost that we started this conversation from.
Nice.
Right.
I know a while back we talked, I forget what company we were talking to, but I mentioned Textron making a lot of aviation parts, and I know they also manufacture a lot of space aviation parts. And since then, it's done very well, and it's kind of a thought of everybody's able to grab an off-the-shelf part, like a bolt or a bearing or a bushing, stuff like that. Textron is a company that kind of makes a lot of that stuff, and then some proprietary stuff as well. But the trick is certain materials require very specialized and expensive equipment to work with these materials in order to develop these parts. That's why I always ask, well, who's making the parts?
Well,
Right.
and I've taught you second order thinking. You
Right.
always want to ask who's making the parts. Sometimes that's the investment opportunity. It's not
Yes.
the obvious. It's not the obvious company. It's who's the one who makes the parts that the winner can't do without.
Right.
Right. So I get another question. Oh, go back. Sorry.
I wanted to hear more about this cryogenic fuel. What is that?
Yeah, so Matthew, to be specific, we're using liquid methane or liquefied natural gas as a fuel and liquid oxygen as an oxidizer. So just for your audience, right, the rockets and space systems, they have fuel, but unlike what you have in the car, there's two components to the fuel typically on a space vehicle, right? An oxidizer and a fuel. And so for us, in our specific case, it's a liquid oxygen and a liquid methane.
And what are other people using for fuel right now?
Right. So some of the competing systems out there, they use fuels that are so-called hydrazine-based fuels, right? Or nitric acid-based fuels. Those are very, very toxic fuel components. They take a lot of handling and management on the ground on Earth before the thing launches into space. It takes a lot of, protective equipment and just a lot of overhead to deal with them, right? There's also other propellant combinations out there, kerosene and liquid oxygen, and finally, at the very high end, expensive end of the spectrum, there is liquid hydrogen and liquid oxygen combination. So the way we fit into this picture is we come in and say liquid methane is the second most traded commodity on the planet after oil.
Yep.
Right?
I had no idea.
And so liquid methane is very, very cheap, or liquid natural gas. By the way, LNG is one of the companies that you can type in, and they're one
we
of the
know
big
LNG.
players.
Oh, yeah.
Typed it in wrong. We know.
LNG. Yeah, they're one of the bigger players out there that sell liquid methane.
Ah, that I did not know. Obviously, we knew from the symbol they do liquid natural gas.
Right.
Which is methane.
Right. So we come in and
Oh, it
say,
is?
well, let's use one of the most commonly traded commodities in the world because of its low price and availability, right?
So let's clarify that. So when we say natural gas, we're really saying methane. Is that right?
Yep.
Okay.
So it's when we say natural gas, it's methane with trace species of other gases, right? Propane, ethane, etc. So we're talking about 95% methane purity when we say natural gas. That's the
Right.
stuff that you burn in your kitchen.
Is it the same stuff
on
you
your
guys
stove.
use, or do you have like a, the better version of that, pure version?
So that's exactly what we go with,
Oh, I see.
the liquid natural gas, right? Our engines can burn the LNG itself straight up.
Wow.
And so back to how we come into the propellant kind of field, right? Is we say our propellant is going to be cheap, but at the same time, we're not going to lose performance. So what do I mean by performance, right? Performance for rocket fuels means, well, how fast can you go, right? The fastest fuel out there is liquid hydrogen from chemical perspective. The middle of the range is kerosene. So we go in and say, we're going to be middle of the range on the order of kerosene, but we're going to be much cheaper because of availability.
Got it.
And
Makes
because our fuels are cold, they can be stored for long durations in those orbital missions. In other words, our OTVs can stay and linger long time in orbit before they execute on a mission.
Right.
As eventually kerosene can break down. It's sort of like leaving gas in your car for too long. It eventually breaks down. It separates essentially. But liquid methane doesn't do that.
You have kerosene on board, right? Let's say you have kerosene on board of your OTV, and it's been 2 months in space. That kerosene will potentially just freeze up on board of the vehicle.
It can gel, just like diesel fuel gels in cold weather.
Exactly. Mm-hmm.
So I'm going to ask you one more tech question. I'm not reading this off a script, by the way. We've concluded an extensive run of 102 cold flow and hot fire tests to validate combustion performance, scale, stability, and reusability across full power range from deep throttle at 10% to 100%. So what does that mean?
Yeah, so what it means is that we go through some serious testing of our components, right? It's a Wild West times in space industry right now, right? And there's some players out there that may come out and say, well, we've developed something, but if you dig deeper into that something, it has not been tested. It's just a pretty picture of some hardware that you don't know how it's going to perform. So we counter that by saying, well, we're going to go and deep dive and do some serious testing of each and every one of our components to prove that our engines are reliable, to prove that our engines can develop the thrust that we're talking about, and they can perform on a vehicle. So for that, we do all that testing. And that is essentially that first comment, the 100 something tests that were done on the combustion chamber. Now, in terms of reusability, it is important to us, and each and every test that we do test the reusability naturally, because we fire those components over and over and over again. If it was not reusable, any of those components, it would just crack or break on the test number, I don't know, 25.
Right.
But we're going through hundreds of these tests, right? And then, you know, in terms of the thrust range, this is important to us because if you think about the orbital maneuvers in space in that upper layer of Golden Dome, you know, the maneuver may not go like you press on the gas pedal and you just go full thrust, right? A maneuver may be something like you start out slow with, you know, slight push on the gas pedal, you go slow and then you accelerate and then you brake you brake at some point again, you know, and so that's the throttling, that's the thrust variations, right, that we're testing for. And we do want to know that the engine can take those thrust variations okay, without braking, without going unstable. Does that make sense?
Yeah, I could see Jay was really into this when he was like smiling the whole time. This is right in Jay's like wheelhouse here. He'll talk your ear off about this stuff for hours at a time. Trust me.
You're a racer, I guess. Jeremy?
I'm a bit of a nerd.
Any other questions, guys? Because I'm going to go straight to some like stock questions, kind of, right? I hate to. All right, go.
Yeah. So, how far away do you guys think we are from like a whole ecosystem in space? Meaning, we've got industry, we've got tourism, you know, that type of thing.
Ankur, you want to?
Yeah, Matt, that's a great question. So you focused on two, you know, so far we've talked about a lot of the space and defense capabilities, you know, missile interception, Star Wars type fights in space, you know, satellites, and that's a lot of what most people think about when they think about space. And it's true, of course, that is happening, and we need to be prepared on that front. Tourism, like you mentioned, Blue Origin, SpaceX, these companies are you know, deep into getting us to other planets, which is also an incredible case. One other case that we're also looking to dive into in service is the whole economy and the whole kind of space infrastructure of in-space manufacturing. And this really has nothing to do with either defense and missiles or tourism. This has to do with helping everyday companies, not just satellite companies, but a wide sector of different companies, get to space to be able to develop products and offerings that they want to be able to sell to their customers. So what kind of companies am I talking about? I'm talking about companies in material science, biopharma type companies, semiconductor type companies. You know, let's take biopharma for an example. A biopharma company, say they're developing human kidneys, maybe they're growing kidneys or human hearts, for example.
Yeah.
They are developing that product on Earth, and there comes a point where low compression, lack of gravity would be an awesome environment for them to be able to take their development to the next level. Well, right now on Earth, that's not an option. We have gravity here. You know, in-space manufacturing is basically all about getting these products, whether it be a human heart or a fiber optic cable being developed by a telecommunications company, to space to be able to take advantage of those zero gravity benefits that will allow them to expedite those product offerings. So right now, a little bit of this is happening on the International Space Station, but it's happening as a one-off case. It's not frequent. It's not common. It's not everyday stuff. To be able to make that happen, low-cost space access and frequent space access is needed, especially for those smaller-sized payloads, which is what we're really focusing on right now, as opposed to massive 1,000-pound-plus payloads. So if you imagine a sample mission, how would that work? You know, Max talked about how the OTV would launch on a rocket, on a small rocket, it would get to space. You can imagine the payload on our OTV is a small 20-kilogram, say, human heart. It goes up into space, it launches to a low Earth orbit or a medium Earth orbit. The heart is developed, it's taken into that final stage of development. And then by means of a reentry capsule, which is where it would be housed on our OTV, we can actually bring that heart back down to the hospital on Earth. The patient comes in and has a heart transplant. So it sounds crazy, it sounds insane, but it's an area through our customer discovery that we've developed. There is a big case for it, and we want to be able to fill that case with our vehicles.
Cool.
So like I was going to ask you guys about this whole cost per launch or cost per ton. I mean, that kind of fits in here a little bit, right? Like, is there any thoughts on that?
Yeah, so Pat, this is a very interesting question. You know, long story short, the launch business, anybody beyond SpaceX, right? The launch business as a whole is struggling with a launch per kilo number, right? What's happening is, you know, SpaceX achieved something like $2,000 to $3,000 per kilo, 5,000. With smaller launch companies, what's happening there is the launch cost per kilo may be as high as $30,000 to $40,000, right? That's the actual effective launch cost. And so the reason why it's happening is because of the economies of scale, right? The smaller launch players out there, first of all, their technologies are expensive. The engines are expensive. The airframe of the rocket is expensive. And so it's hard to break even for those companies. And so you jack up the launch cost naturally. Whereas SpaceX, it has relatively low-cost engines and the airframe, and it has significant mass production capability behind to support the low cost, right? And so the answer, the only answer to that conundrum going forward into the future, right, is to bring down the cost of the engines and the airframe. And it starts with the engine, that story, right? How do you do that? How do you really bring down the cost of the engine? How can you be smart about the technology of the engine itself? And so this is basically where we're spending a lot of time and thought process on, right? How do you really bring down the cost of the engine by 10x?
So what's the
And
number? Like, where's like the kind of the line where the costs get to where, cool stuff starts happening? I don't know. Is it at $2 a kilo or $10 or 1,000 or what would that be?
yeah, so in our specific, let me give you our specific kind of projection, right?
Yeah.
If you have an engine that is $150,000, you can build a rocket that launches for $1.5 million into space. This is when you have all of your engines on that rocket brand new, unused, right? Then you keep flying the booster, you keep reusing the booster, and at some point on launch number, say 6 or 5, you get down to $500 a kilo. On launch number 7, 8, you get down to $200 a kilo, right? And that's the number, I believe, that opens up space for regular business, right?
Got it.
Not the Mars, colonization type significant endeavors, right? Not flying to Jupiter, but for regular business, like Ankur alluded to, right? We're talking about manufacturing in space, making goods that can only be made in space. At $200 a kilo, what it means for a business that wants to make a product in space is that my launch cost is going to be just a fraction of the product and revenues that I'm going to make on these products that I made in space. Does that make sense?
Yeah.
And it goes.
Absolutely.
It circles back to the low-cost engines.
There seems to be a disconnect for the general public and what the space industry is doing. So Space isn't just the playground for the wealthy. There's a lot of applications that affect us day to day. And once you get those costs down to that level, there's a lot of exciting things that, we can do.
Well, I'm in my early 30s, right? So will this happen in my lifetime?
Sure, of
Okay.
course.
Definitely, yes.
Okay, good. You like that one, Matt?
Yeah. You're
Early
celebrating
30s.
the 30th anniversary of your 30th birthday.
All right. So I'm going to switch gears a little bit here. So, all right. So, I mean, this is kind of a formulated question, but not really. So, like Rocket Labs, Astrospace, any thoughts on those guys? Or, I think one thing we've all recognized here in doing this podcast is that, like, a lot of the cool companies out there in space and drones and, I don't know, Golden Dome and all that are private, right? So we have like a limited universe of companies to talk about. So we always go back to like Rocket Lab and Astrospace, Northrop Grumman, Aerojet, Lockheed.
I
Any
think
thoughts on any of these public traded companies?
I think Lunar's getting killed today. Eesh. Yeah.
Yep.
Um, I guess from my perspective, all we can say is general things
Yeah.
that
Anything's good.
are out there in the public domain, right? Rocket Lab wise, this is a very successful company. It's the only company, in my opinion, that is really flying to space beyond SpaceX at a cost that makes sense, right? So
Okay.
if you kind of lay out the land in space industry right now, it's SpaceX, it's ULA, Blue Origin. Those are the big rockets, right? But
Right.
the only player in kind of the small rocket arena is Rocket Lab. Firefly is getting there, but the cadence of launches, the number of successful launches that they had is still that's still evolving. Rocket Lab has flight heritage behind them. They have a technology that delivers, and it's reliable, and it's consistent. So in terms of Astra, that story is a little bit different, right? Astra is not Rocket Lab, just so you can understand kind of the big picture. Astra is
ASTR.
still, in terms of
Oh.
technology, it's still a developing story, right? They had a number of launches, but the success rate is still evolving as a metric for them. And yeah, that's about all I can say.
Isn't ASTR and ASTS two different things, Matt? I think I think ASTR is Astra and AST. What? So, oh no, so they're the same thing. Okay, maybe they are. All right, my bad. All right. So you mentioned Firefly. I'm just going to ask you a question about Firefly real quick. So, Firefly has something going on the other side of the moon in theory. I mean, what does that mean? Or why would the moon be important in this case? Because I know you guys are in the lunar business as well, right?
Well, so specifically for us, the OTV can potentially perform lunar missions, lunar transport from low Earth orbit to moon if needed. Now, in terms of lunar missions in general, right, for about 5 to 10 years, these past 10 to 5 years, what was happening is there was a strong push to use Moon as an intermediate base to then travel to Mars, right? The idea was to establish a lunar base to basically anchor down there, establish fuel depots, the infrastructure, and then using extremely low lunar gravity, launch stuff from there to Mars, which would be much easier, theoretically, right? And so because of this at the high level, many kind of players emerged that said, well, we're going to make these lunar landers that are going to transport the first infrastructure components to the moon, right? And so you have Intuitive Machines, you have Firefly, You have Astrobotics with their lunar lander technologies that go to the moon and do the trial missions. Now, each one of those missions is extremely complex if you kind of take it at a technical level, right? But what we can say is that each one of those flights and missions to the moon was a success, technologically speaking. It's a challenge, and even though they were not perfect, some of these missions, it's still a significant success on that roadmap to establish a base on the moon.
Right. Okay. All right. Jay, you got anything in here?
I do actually.
All right, go for it. I knew you did.
I was kind of wondering what's the primary material that your engines as well as the vehicles are made out of? Is it titanium or more nickel or kind of all of the above?
Yeah, so excellent question, Jeremy. Again, we tinkered a lot about what materials should be used in our engines, right? And the first order instinct is to use very expensive materials in your rocket engines. Well, you think, well, it's a rocket engine, and so it should be very, very exotic in its materials because of all the heat that is coming out, right? Because of the combustion.
Right.
Well, we approached it differently. We said, what are the low-cost materials that can still withstand the combustion environment inside of the engine? And again, we're coming at this from a low-cost angle, right? The whole, architecting the engine was done from that perspective. And so for us, it's more of stainless steel type alloys, nickel-based alloys that are on the low cost of the spectrum of available metals out there. So we do avoid expensive metals in our engines.
So I'm going to put you out on a limb here, right? So would you say then rare earth metal craze hype, is that hype or is that real?
Pat, you're talking about rare metals
Just as a whole.
just
Like
as a whole?
Yeah, do we need all these exotic, expensive, rare metals, or can we do it with,
Not for his engines. But
Yeah.
we need it for
I mean, do we
everything
need it for everything?
We don't. Again, Pat, it's
Cost effectiveness.
it's a little bit of lazy thinking,
That's
right? If you
else.
have,
That-
No, that's you, he meant. Go ahead.
what's that?
So
Nothing. Go ahead. Go ahead. No, it's a little bit lazy thinking. What? Go ahead. I'm sorry.
Yeah, it's a little bit of lazy thinking if you have a very hot object, right, and you right away jump to very expensive materials to cover for that.
Right.
And when you're talking very expensive materials, you're talking rare metals right away.
Yep.
I think, in my opinion, you can be pretty smart about how you approach the design itself, so
Right.
that you don't go to the extreme of the rare metals, right?
Right.
Especially considering the geopolitical situation right now, when the access to the rare metals may be limited going forward.
Right. So okay. I mean, that's interesting. I'm gonna read up on that. You know what I mean?
So-
It's interesting. How rare are how necessary are these rare earths really? Okay.
My-
Go ahead, Jay.
if I interject a little bit, my point was so launch vehicles coming down in cost means yes, going to less exotic metals like stainless steels, which utilizes a little bit of chromium and nickel, of course, and some other alloys in the mix. The other side of this is okay. Well, that's going to scale out. Let's say they sell 1 million of these engines, uses a lot of material, but it's less exotic material, so it's not as huge of an impact on smaller rare earth metals, more rare stuff. But what it leads to is if you've got all this production in space, I mean, particularly in like material stuff, like semiconductors that can be made in zero gravity much more efficiently than they can on Earth. So the rare earth metals will still be necessary for a lot of that stuff. A lot of the development and a lot of the equipment that'll be up there operating is of course going to require a lot more rare earth materials. But the idea is that, let's say later, I'm not seeing like, an orbital Amazon distribution center, but if you get enough manufacturing going on in space, you're going to be kind of equivalent to the electronic consumption of such a structure. So in theory, as this ramps up, so will the rare earth metals and more exotic materials later. But it'll also reserve some of the exotic metal alloys like titanium and nickel alloys, which are highly expensive, for use in other things. Maybe that comes down a little bit. So some of the more exotic things you would need, tools and equipment, whatever, those prices will be stabilized in that long stretch. So in the meantime, who makes the money on that? The guy's digging it out of the ground.
Right. All right. One last thing, then last thing here. So just real quick, we talked about this a little bit, but we talk about hedges, edges, asymmetric risk and themes here. That's what HEAT is. And I keep coming back to the same thing about the edges being government contracts, which you guys have, right? I mean, is there any last comment about how important that is, or how necessary that is, or how meaningful that is?
So Pat, just to paraphrase your question, how important is it to have a government contract in our business?
Yeah, something like that. Yeah.
Okay. Well, it is very, very, very important. I cannot emphasize it enough, especially with a high-profile agency such as Space Force, right? The impact here behind a government contract is not only the money that it gives to develop the thing that you're trying to develop, but it's also the future potential of collaboration with the government. Government is the biggest buyer on the planet, US government.
Right.
You can't underestimate the resources our government has. And so for any player out there like us, to have a government contract means that there's going to be future opportunities that are going to scale up in significant quantities, right? And Ankur, if you want to talk about kind of the projections that you
go for it.
thought about.
Yeah, so as we look forward to the next few years on our end, the government contracts and commercial sales are both going to kind of make up income streams for our company, starting off with some of the rocket engines that Max has talked about over the course of this podcast. We want to be able to start supplying our engines for small launch manufacturers, small rocket manufacturers who are ready to start getting their small rockets into space. In addition to that, on the basis of the contract that we're on right now, we're currently developing this prototype of this orbital transfer vehicle. Well, we want to start being able to field this vehicle in numbers by the end of this decade, by 2029, 2030, in large scale quantities called constellations for both commercial and DoD purposes. On the DoD side, it could be used to launch satellites for reconnaissance missions. It could be used for commercial companies for a range of different use cases. So when we look to the future, we definitely want to enter kind of the revenue streams with engines, but quickly scale up to OTVs and some of the other missile technologies that we're developing. And we plan to start this by year 2020, end of 2026, going into 2027.
Right.
Yeah, and if we circle back to that upper layer of the Golden Dome, right, there's varying estimates of what those constellations of sensors, vehicles should be like in numbers. And so the estimates range from several hundred to 16,000 type numbers, right? So if we scale up into further government contracts, then we may be potentially talking about hundreds or thousands of these OTVs in space.
Wow.
And that's where a lot of the rare earth metals will be, is in those sensors.
Right. I
That's
see.
correct,
Yeah.
Jeremy.
see.
But let me clarify something. So we're not in the business of making the sensors themselves,
You just
Right.
move them.
right? That's our customer
Right.
that puts a sensor on our vehicle, right? So from this perspective, we're pretty agnostic into about what happens about the rare earth metals that go into those sensors, right?
Right. Yeah.
Exactly.
Okay. So where do we find you guys? It's Rocket. Matt, want to pull these guys up? RocketPropulsionSystems.com. No, it's RocketPropulsion.systems, right?
It is rocketpropulsion.systems,
I like
and
that.
you can always email us. There's contact page there. Yeah, or just email straight up to us as well, and or LinkedIn. We're present on LinkedIn and we're active.
Right.
I like it. Looks
Great
nice.
stuff.
Heck yeah.
If I
Let me
needed
just
any
dumb
rocket
question, but
engine, I would use it.
who designs this stuff, right? Like there's that one, Mike Myers thing or whatever. How do you make these things look so cool?
Just very carefully.
All right, that's good answer.
It's inherent with the design to
That's
look cool.
That's a Matthew Tuttle answer, by the way.
Everything comes from functionality.
Yeah.
You can tell that a lot of space hardware doesn't look like, what you see in movies.
Yeah, right.
for sure.
Pat, they're looking for a manufacturing engineer. If
Oh,
things scout
there you
for
go.
here.
No.
There
Like,
you go.
okay, like I'll go make a degree here real quick on ChatGPT. I'll send it in to you guys.
There you go.
Which college do you prefer? All right, I'll see you guys later.
We'll see
All
you
right,
guys
thanks
next week.
Have a
Coming,
good
guys.
weekend.
See you guys.
Thanks, everyone.
Bye.
Bye.
Thank you.